In this example, we're asked to find the value of C for which the vector 5, 4 is not in the span of these two vectors here. Okay, so if it's not in the span, that means that there are not numbers, let's say S times the first vector, plus, let's say, T times the second vector, such that this linear combination is equal to 5, 4. So we want to find the values of C for which this won't work, right? Because if it is in the span, if we can do some number times 2, 1 plus some number times C3 and generate 5, 4, that would mean that it is in the span. So we want this equation right here to not have a solution, right? If if 5, 4 is not in the span, then this is not possible. So we need to find a value of C such that this equation right here does not have a solution. So it's inconsistent. So we're looking for C that'll make this system inconsistent. Okay, well, so this vector equation right here, if you do the vector arithmetic, so if you do S times this first vector, you'll have 2S and then 1 times S, plus T times that second vector, so I'll have plus T times C and then plus 3T, is equal to 5, 4. So that corresponds to the system of equations 2S plus T times C equals 5 and S plus 3T equals 4, which corresponds to the augmented matrix 2. Okay, then let's be careful. So the columns here are going to represent the coefficients of S and T. So 2, and then the coefficient of T right here is C. C is some number. We just don't know what it is right now, but so it's like, say, 17. So whatever C is, that's the coefficient of T, equals 5. And then 1S plus 3T equals 4. So now we should row reduce this thing and then evaluate what C would have to equal for this to represent an inconsistent system. So the first thing I would do is swap row 1 and row 2, get that 1 up in the top left corner. You know, that always tends to make things run more smoothly. Okay, so this will be 2C5. And then I want to get a 0 in this position here, so I would do -2 times row 1 plus row 2. So that'll give us, let's see, -2 plus 2, so that's 0. -2 times this will be -6 plus C. So I'm going to write that as C minus 6. I mean, I said -6 plus C, but these expressions always look nicer with a positive term in front. And then -2 times this, so that's -8 plus 5, so -3. Okay, so this thing's now in reduced echelon form. So we can start thinking about what this would need to look like if it's inconsistent. Remember, where you want to find C so that 5, 4 is not a linear combination. So it's inconsistent when you have a pivot in the constant column over here. We would want this guy right here to be a pivot. And remember that the definition of a pivot is the first non-zero entry in each row, the first non-zero entry. So that means if we want this guy to be the first non-zero entry, this would have to equal 0. So in order for this system to be inconsistent, C minus 6 would have to equal 0, and so C equals 6. And just looking back, note that if C is equal to 6, then this last row will be 0, 0, -3. And there's your inconsistent system.